Hey guys, this is Alan with Bothell STEM Coach, and today we are continuing on with the 2015 AP Calculus AB free response questions, and here is number 5. The figure above shows the graph f prime, the derivative of a twice differentiable function, f, on the interval -3 to 4. So this is f prime, and so I can take the derivative of this. There's probably a lot more derivatives I can take, but at least I know I can take 2 derivatives of f. The graph of f prime has horizontal tangents here, x equals 1, here, and x equals 3. So they're just being very explicit that where those occur at. They're horizontal tangents there. The area of the regions bounded by the x-axis in the graph f prime on the intervals. Oh, okay. So now they're telling an area. -2 to 1. This area here is 9. And this area here, I assume between 1 and 4, is 12. Okay. Find all x coordinates at which f has a relative minimum. Okay. Relative maximum. Maximum, first I need to find the critical point. So I need to know when f prime equals 0. Well, that occurs at x equals -2. Because this is the graph of f prime. It being 0 is when it crosses with a y value of 0, crosses the x-axis. X equals -2, -1, and 4. You can't have relative maximums at the end points of your interval. So 4 I can't exclude because 4 is the end point. And I can't have relative max there anyway. My other candidate is not -1, +1. I don't know what I'm thinking. It's 4, 1, and -2. Okay, so at +1, see how f prime before is negative and negative? That means, like, if I do the first derivative test, it's negative to the left of 1 and negative to the right of 1. So the slope, while it goes to 0, it stays negative to the left and right of 1. So it's not that one. And then -2 is the only one. So let's see, the slope is negative and then, it's positive because it's above the x-axis and then negative. So if it's positive and then negative, it makes it a maximum. So this is the only time where f prime is greater than 0 to the left of x equals 2, and f prime is less than 0 to the right. X equals 2. Okay, so that's A. Let's look at B. On what open intervals contained in -3 to 4 is both the graph of f both concave down and decreasing? Okay, decreasing is when it's less than 0. Concave down is where the second derivative is 0. Okay, so the first derivative is negative on the intervals from -2 to 1 and 1 to 4. Okay, it's actually negative over this whole region for the most part, except for where it crosses the 0 point. Okay, concave down is where the slopes of this are negative. Right? Because second derivative is the first derivative of this one. So second derivative looks like slopes on this graph. Right? Because the slopes of this graph would be the derivative of this graph, which is the second derivative of f. Okay, so the slopes here are negative between -2, -1, and then 1 to 3. And if I look at what overlaps here, this interval and this interval, so my answer is -2, -1, union with 1 to 3. Okay, those are the intervals. I think this is good enough reasonings, because here slopes of f prime are less than 0, and here f prime is below x-axis. C. Find the x-coordinates of all the points of inflection for the graph of f. Give a reason for your answer. So now I want to know points of inflection are where the second derivative equals 0, and then the second derivative changes signs. So where the second derivative equals 0 are where, again, because the second derivative of f looks like the derivative of f prime, they look like the slopes. The critical points here are -1, 1, and 3. It's where the slopes of f prime are horizontal. Or tangent lines of f prime are horizontal. Okay. But I need the second derivative to change signs. So the second derivative, again, are the slopes, and then the f second derivative changes sign. Slopes of f prime at all 3 points. Because the slopes go from here, it goes from negative to positive, here it goes from positive to negative, here it goes from negative to positive again. So all of these points are points of inflection. This is sort of these are the two requirements for a point of inflection. The second derivative 0 and the second derivative changes sign. Now, given that f of 1 equals 3, write an expression for f of x that involves the integral. That involves an integral. Okay, so f of x is equal to f of 1 plus the integral from 1 to x of f prime of t dt. Okay, this is fundamental theorem of calculus. So this is f of x is equal to 3, because they say f of 1 is 3. Integral 1 to x f prime of t dt. Okay. Now f of 4 would be equal to 3 plus the integral 1 to 4 f prime of t dt. So the integral is the area between 1 and 4. Now they said this area was 12, but because it's below the x-axis, the integral is negative 12. So f of 4 is 3 minus 12, which equals negative 9. Then f of negative 2 is equal to 3 plus the integral from 1 to negative 2 f prime of t dt. When I integrate from 1 to negative 2, the area is 9. Because it's below the x-axis, it's negative 9. But because I'm going from right to left, that adds a sign. That makes it positive 9. Equals 3 plus 9, which equals 12. Okay. All right, let's look at the scoring guidelines. Relative max at x equals negative 2. Negative 2 to negative 1 and 1 to 3. Yep. The graph is a point of inflection at x equals negative 1 because f changes from decreasing to increasing. Has a point of inflection because f prime changes from increasing to decreasing. Okay, the sign changes. I don't really know if like you have to justify. So all 3 of the points are. Identifies that and gives a reason. And then f of, that looks right. F of 4 is negative 9. F of negative 2 is positive 12. Okay, cool. Thanks for watching, and we got one more free response question left, so we'll work on number 6 in the next video. Thanks. Thanks for watching the video, guys. I just want to let you know that I offer free homework help on Twitch or Discord, so just stop on by if you have any homework questions or you just want to learn about different parts of math and physics and hang out. Hope to see you there.